In this example, I'm going to demonstrate task parallelism and data parallelism. So this simple model is testing different ways of connecting input components and output components. The technicalities are not important here. What the pipeline does, and each of those pipelines does, is it reads an input EM and it performs two operations on it. The first operation is to square the image values, and the second one is to take the square root of the images. The images are named based on the tests and what image was produced. So we've got 4 of those tests. Each produces 4 images. And to see whether the test was successful, we compare for each of the tests the test image with a reference image. And this component then writes text files where we can see whether the test was passed or not. And this component then reads all those 4 text files using sort of like a simple command line script, and then writes those information into another file. And have a look at that. So first we run this model. We see the model is executed sequentially, as I explained before, based on the time levels. So this component first, then this, then this, then this. And then the testing was done, and the tests will read out. And these are the results we get. As we can see, is that each of the names here for the text files, as well as for the output images, are individual names, so they are unique for each of the tests. So actually what we could do is process those tests in parallel. So those tests, and we could also process the verification in parallel. However, this still needs to be done in sequence, as we want to write the outputs in order. So what we can do now to turn this into a parallel model is we put all of those different components here sitting at different time levels on the same time level. So let's put all of those components on time level 2. So this one, 2. This it's already on 2, and this also on 2. And then see what happens. So we delete all of those, and we check our compute resources. So let's take 5 threads and 4 processes, because we want to basically run those 4 components in parallel. So 4 processes is all we need. So now we run this model. And we can see that those 4 tests were executed in parallel. The feedback is not always perfect. So that way this group component didn't show active, but we saw that the pipeline was running at the same time. And we also saw that those were computed at the same time, and they appeared so almost at the same time. The writing is still in sequence, but there's very little lag between those. Let's do it again. Okay. The next level of parallelization we can do is we can actually perform those tests that were run in sequence also in parallel. And all we have to do here is that we convert a sequential iterator into a parallel iterator. And this is all it takes to do the conversion. And now we can run this test again. So now we clearly saw that those components were executed in parallel, and also tests were done in parallel as much as possible. The allocation of compute resources here is explicit, and they are allocated step by step on the sort of sequence of execution. So we saw that these components here sit on the same time level. That's why they were executed in parallel. But at the same time, they're sitting on a higher time level than those components. That means that these components were executed first, and the available compute resources, so the 4 processes we have allocated, were allocated amongst those ones. And then the 4 processes, once this was finished, the 4 processes basically were used to create 4 parallel processes, testing those images. And each of those processes did 2 iterations to test those pipelines individually.